Simple Harmonic Motion by Ash Zone. Today's our topic is about the numericals. So let's start. 10.1. The time period of a simple pendulum is 2 seconds. What will be its length on Earth? What will be its length on the Moon if the gravitational of Moon is gravitation of Earth upon 6 and where the gravitation of Earth is 10 meter per second square. So we'll format the data. Time is equal to 2 seconds. Length on Earth is equals to unknown. Length on Moon is equals to unknown. Gravitational acceleration on Earth is 10 meter per second square and gravitational acceleration on Moon is 1.6 meter per second square. So for Earth we'll use the formula T is equals to 2 pi under root L of Earth and G of Earth. T square is equal to 4 pi square L of Earth upon G of Earth. Length of Earth is equals to T square into 10 upon 4 pi square and the answer is 1.02 meters. And for Moon we'll use T is equals to 2 pi under root L upon G and we'll form the same formula as the time period is same. So Lm is equals to 2 square into 1.6 upon 4 square and 0.17 meter is the length on Moon. Moving on to the next numerical, 10.2. A pendulum of length 0.99 meter is taken to the Moon by an astronaut. The period of the pendulum is 4.9 seconds. And what is the value of G on the surface of the Moon? So L is given, T is given, we have to find the G. So we'll use the formula. T is equals to 2 pi L upon G. Tm square is equals to 4 pi square under root Lm upon G. G is equals to 4 pi square into 0.99 upon 4.9 square. Gm is equals to 1.63 meter per second square. Moving on to the next numerical, 10.3. Find the time periods of the simple pendulum of 1 meter length placed on Earth and Moon. And the value of G on the surface of the Moon is 1/6 of its value on the Earth, where G is 10 meter per second. So time period on Earth is equals to time period on Moon, which is unknown. Length is equals to 1 meter. G on Earth is 10 meter per second and G on Moon is 1.67 meter per second. The solution is that we'll use the same formula. T is equals to 2 pi under root L upon G as the length is same on Earth and Moon. For Earth we'll use 2 pi under root 1 upon 10 is equals to 2 seconds. And for Moon we'll use the same formula, 2 pi under root L upon G, 2 pi under root 1 upon 1.87 which is 4.9 seconds. Moving on to the next numerical, which is 10.4. A simple pendulum completes one vibration in 2 seconds. Calculate its length when G is equals to 10 meter per second square. L is 1 meter, T is unknown and G is 10. So we'll use the same formula. T is equals to 2 pi under root L upon G. T square is equal to 4 pi square upon L upon G. L is equal to T square into G upon 4 pi square. 2 square into 10 upon 4 pi square. L is equals to 1.02 meters. If 100 waves pass through a point of medium in 20 seconds, what its frequency and the time period of the wave? If its wavelength is 6 cm, calculate the wave speed. F is unknown, T is also unknown, where the lambda is 6 cm or 0.06 meter. N is equals to 100 and T is equals to 20 seconds. First of all, we know that F is equals to N upon T. So 100 upon 20 is the frequency, which is 5 Hz. Then we'll calculate the time period. T is equals to 1 upon F. T is equals to 1 upon 5, which is 0.2 seconds. Now we have both frequency and the time period. Now we calculate V is equals to F lambda, which is F 5 into 0.06 which is equals to 0.3 meter per second. Next numerical is 10.6. A wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 cm. What is the speed of the wave? If f is equals to 12 Hz, lambda is 3 cm which is equals to 0.03 meters, and the speed is unknown. We'll use the same formula. V is equals to f lambda. So 12 into 0.03, which is equals to 0.36 meter per second. Moving on to the next numerical, 10.7. A transverse wave produced on a spring has a frequency of 190 Hz and travels along the length of the spring of 90 meter in 0.5 seconds. What is the period of the wave? What is the speed of the wave? And what is the wavelength of the wave? If f is equals to 190 Hz, time period is unknown, v is unknown, and the lambda is also unknown. So we'll know that t is equals to 1 upon f. So t is equals to 1 upon 190. T is equals to 0.005 seconds, which is equals to 0.01 seconds. Now we know that v is equals to d upon t. D is 90 and t is 0.5. So v is equals to 180 meter per second. Now v is equals to f lambda. We'll calculate lambda by crossing the formula. Lambda is equals to v upon f. Lambda is equals to 180 upon 190. Lambda will be equal to 0.95 meters, which is the wavelength. Moving on to the next numerical, 10.8. Water waves in a shallow dish are 6 cm long. At one point, the water moves up and down at a rate of 4.8 oscillations per second. What is the speed of water waves and what is the period of the water waves? Lambda is equals to 6 cm, which is equals to 0.06 meters. F is equals to 4.8 Hz. V is unknown and T is also unknown. As we know that the V is equals to f lambda, V is equals to 4.8 times 0.06, which is 0.29 meter per second. T is equals to 1 upon f, which is T is equals to 1 upon 4.8. T is equals to 0.21 seconds. Moving on to the next numerical, 10.9. At one end of a ripple tank 80 cm across, a 5 Hz vibrator produces waves whose wavelength is 40 mm. Find the time the waves need to cross the tank. If f is equals to 5 Hz, lambda is equals to 40 mm, which is equals to 0.04 meters, and time is unknown. So let's check the solution that we know. If v is equals to f lambda, v will be equal to f 5 times 0.04, which is 0.2 meter per second. If v is equals to d upon t, 0.8 upon 0.2, v will be equal to 4 seconds. Moving on to the last numerical, which is 10.10. What is the wavelength of the radio waves transmitted by an FM station at 90 MHz, where 1 MHz is equals to exponent 6, and the speed of the radio wave is 3 times exponent 8 meter per second. Lambda is unknown. F is equals to 90 MHz, which is equals to 90 times 10 raised to power 6 Hz, and V is equals to 3 times 10 raised to power 8 meter per second. Solution is simple. V is equals to f lambda. Lambda will be equal to v upon f. Lambda is equals to 3 times exponent 8 upon 90 times exponent 6, and lambda is equals to 3.33 millimeter, which is the wavelength. It's the end of our numericals. See you in the next video, which would be of the conceptual questions. Till then, goodbye.